Hey guys, how's it going? In this video, I'm going to walk through this one of the most classical problems in Leetcode, alien dictionary. This problem was asked by Facebook and Amazon more than 10 times in the past 6 months, and let's dive in. So there is a new alien language that uses the English alphabet. However, the order among the letter is unknown to us. So you are given a list of strings words from the aliens language dictionary, where the strings and words are sorted lexicographically by the rules of this language. It will return a string of the unique letter in a new alien language sorted in the lexicographically increasing order by the new language rule. If there is no solution, just return an empty string, and if there are multiple solutions, return any of them. A string is lexicographically smaller than another string if the first letter where they differ, the letter of in S comes before the letter in T in the alien language. If the first, so this is the minimum length, letter are the same, then S is smaller if and only if the length of S is smaller than the length of T. Let's look at some more quick concrete example. The words will be given is WRT and looks like this, and the dictionary that returned it should be WERTF. So essentially, this is the relative ordering, right? So how this is being produced is that, let me walk you through a diagram. So when we scan through these words, right, and the first word, first pair, so we scan through this word in pairs, basically. Let me zoom in a little bit so you can see more clearly. So, for example, the first word, right, first two words, first pair of words, right, WRT, WRF. As you can see, here is W, they are the same, right, and then the next character, next is R, still the same. The last one is T and F. So we know that the WT comes before WRF, WRT comes before WRF. So the information we can extract from here is that we can know that the T should come before the F in this aliens language. Okay, so that's the first information we found. Okay, so this is the first pair, right? And then the next pair is going to be this one over here, WRF and ER. So the first letter that they differ was the first one, right? So W is not the same as E, right? So we know that in this language, W should come before the E. Okay, so this is the second piece of information, comes from the second pair. And the third pair is the is the ER and ETT. And the first letter, they are the same, so there's not much information contained. Second letter is R and T, right? So the information we extracted is that R comes before the T. Okay, the last one, the last pair will be ETT and RFTT. So the first letter they differ already. So we know that from there we know that it's gonna be E comes before the R, right? So that's the last piece of information. And what we can do is to organize these pieces of information. So we know that the T comes before F, right? And then we know that the E before the W before the E, and then we do some logical reordering. We can know that the W comes before the E, right? W before the E, and E before the R over here, and R before the T, and then T before the F. Just some reordering of this information and concatenate each one of them. So this is this answer. So this is exactly that. Okay, and this is not very ambiguous. And that could be a case where multiple solution may be possible if there is no continuous connection between them. So it could be multiple solutions. So that's the first example. Oh, also in a case where if there is a cycle, right? If we find out subsequently the F also comes before W, so this will be a invalid dictionary. In this case, we have to return a empty string because you can see there's a cycle, right? So W to E, E to R, R to T, T to F, and F to back to W, which is the beginning, right? So we can see there's a cycle going on, and in this case, it's going to be invalid, right? Invalid dictionary. So in this case, we're going to return an empty string. We detect a cycle, and consider the case where if the given answer looks like this. So we know that the W before the E and R before the T and T before the F. So we do not know is it this one should come before this part or this one comes before that part, right? If in the situation looks like this, so we can return in any order. So this is the ambiguity that I talked about. So we can return the answer in any order that we want. So that's the first example. And second example looks like this. So we have the two words, one is Z and XX. By this method, we know that the Z comes before the X. So pretty straightforward. Oh, and this is the one that has a cycle, right? Z comes before the X, and X comes before the Z again. So the Z comes back to what it was before, right? So gonna be an empty string because there's a cycle invalid. Okay. And also, yeah, there's a constraint over here. The length of the word, also the number of words, the word count. And also, yeah, this is kind of important, right? It's only so we know the scope, right? Only containing the lowercase English letters. Okay, so this is the introduction of this problem, and we were going to solve this problem with topological sorting with graph. Okay, let's dive in. So the first concept I'm going to introduce is the concept of in-degree. As you can see, for those of you may not be familiar, I wasn't familiar with this concept of in-degree, so I did a lot of research around on that. What actually is in-degree? So in-degree is actually just the number of incoming. The number of incoming pointed to that letter. Okay. Let me try to explain it in an example. For this one that we talked about, right? So the in-degree, for the in-degree of W, it's going to be 0. There's no incoming, right? There's no incoming for the W letter, so the in-degree is going to be 0. And for the E, the in-degree is going to be 1 because the incoming going to be W to the E. Okay. And also the in-degree of R is going to be 1 as well because there's only one letter comes to the letter R. Okay. And then by the same logic, the in-degree of T and the in-degree of F is going to be 1 as well. So let me give you another example, okay? If we have a dictionary, looks like this. So A to B, A comes before B, and also at the same time, C also comes before B. So what do we think of the in-degrees, okay? The in-degree of A is going to be 0 because there's nothing comes to A, okay? And also the in-degree of C is also 0 because there's nothing comes to C. But the in-degree of B is going to be 2 because there are 2 letters comes to the B. So in-degree, I think the best way to explain it is like as the priority. The lower the in-degree, the higher the priority. Okay, so I hope that I'm explaining myself clear. So this is the key to solve this problem. So again, let me write down over here so we can see. So the in-degree of A is going to be 0, and the in-degree of C is also going to be 0, and the in-degree of B is going to be 2. Okay, based on this one. And again, so the lower the in-degree, the higher the priority. What I mean by that is the solution could be A and C and B. So that's one of the possible solutions, right? And also it could be C and A and B. Okay, and as you can see, because we don't know the relative position between A and C, so that's why these two solutions are valid. Both of these solutions are valid. And what we are sure is that the B always come at the end, at last, at the end, right? So the reason why is that because we have the in degree of 2. The in degree of 2, the in degree of B is too high, which is too high. That's why it has a lower in priority. So when we deal with this guy, we have to deal with these two guys first. So that's why A and C must come before the B. That's why A and C has a higher in priority. After we get the A and C out of the way, and then now we can deal with the B. That's why the B has a lower priority. Okay, I hope this is clear. If not clear, I will jump in the code and then it's a lot more clear to you. Okay, let's dive into the code. So first thing, we have some initial setup. We have the out to in. So basically this is a dictionary. The element is going to be a set. I use a default set. Sorry, default dictionary. So the default element will be a set. So the key is going to be something comes out, and the value is going to be a set that contains something comes in. Okay. So for example, for this guy right here, right? So if we can change, we can record this message in a dictionary. So the key, for example, the key is going to be a T, right? The letter T, and the value going to be a set. The set that contains the letter F, because T comes to F, and W comes to E. W comes to E, right? And this is exactly this one. I call it out to in, right? Out from W to into E. I hope this is clear. And this is how we build up the graph. Okay. And also we have the integrate dictionary. So this is exactly that. Okay. For all the letters, for all the words, for all the letters or a character in the word, the integrate initializes as 0, and then we will update this value after we traverse the graph. Okay. Okay. So now what we're gonna do, we have this for loop. So this is actually exactly what we just did at the beginning, right? Remember we compare those words in pairs. Okay. So we have for example, when the I is 0, so we're comparing the first pair, and if the I is 1, it's comparing the second pair. So we look at the words in pairs, and the mean length is gonna be the minimum length of the first word and the second word. Okay. Because if we go outside the outside the mean length, it's nothing to compare, right? Because one of them is shorter. And now we have a font diff. I'm gonna explain to you why I need that later. So for all the J index in the range of the mean length, and look at the first word of the J. So basically now this for loop we comparing the characters of the two words. Okay, I have a two words, right? And I have the out character, also I have the in character. Again, so the reason why I call it out and in, because let's say for this one over here, let's look at this pair, right? WRT and WRF, and this is the first word and second word, right? And remember the information we extracted was the T comes to the F. So the out will be the T, in will be the F. I hope this is clear, right? So we keep scanning through these two words until we find a difference, which is the T and F. So the out is going to be a T and in is going to be the F. Okay, and this is exactly that. Okay, out character and in character, right? Out and in. And now after we found the out and in for the first difference, okay, and then we stop. Actually, that's why we have the break. We don't have to look through the rest of the two words. Okay, and if so, here is where we build the graph. Okay, if the in character is not already in the out to in graph dictionary that we initialize it, if not in it, what we're gonna do is to add the in character to this dictionary, to that set. Okay, again, it could be multiple. The reason why we use the set, because there could be a multiple number that come out and then come into a certain direction, right? So it's not necessarily like it could be a multiple to one. Sorry, it's going to be a one to multiple. Yeah, because that's why we use a set. Because one letter can be go to a different letters later on. That's why we use a set. And now we know that there's something come into the in char, and that's why we increase the in degree by 1. And this is exactly this one. Okay, A to B and B and C to B. So there are 2 incomings. That's why the in degree of B is going to be 2. So each time we come across a letter of the incoming, and we just increase the in degree of the in char by 1. Okay, and also we have the found diff of set it to be true. So again, now I'm going to explain why I need to found diff. So in the case where if the first word looks like this, UFO, and the second word looks like UFOA, right? So the shortest length will be the first 3 characters, right? And then after we compare the 3 characters, we out. We exit from this folder, we are out. So, but we didn't find any differences, right? Which is okay. So in that case, we never jump into this if statement, right? For this one, we never jump into this if statement. So in that case, we will have the found diff will be set to be false at all time when we compare these 2 words. Okay. So let's consider 2 cases, right? If the first word is UFO, second word is UFOA, which is fine. This is okay because the first word is the length is shorter than the second word. However, if the first word is longer than the second word, this is not okay, right? So this is exactly what is comparing, right? If we haven't found any differences, and if the length of the first word is even longer than the length of the second word, which is this case, this is not okay. So we break out the whole thing and then we return an empty string. Okay, I hope this is clear. So this line of code is captures exactly that, and this is found diff just for that. Okay, so now after we build up the graph, and now we can do the rest. So first, we again, as what I said before, and I'm hoping to make this clear. So the lower the in degree, the higher the priority, right? So the higher the priority, we deal with them first, and we have to deal with the higher priority characters first, and then the lower priority characters later. Okay, this is exactly what we're gonna do. And I have the list, so I call it 0 in degree characters, which is all the characters in the in degree dictionary if the in degree is 0. So this character has the highest priority. I initialize it. Okay, that's why I call it 0 in degree characters. And now I have the result, which is empty list, which I'm gonna turn it into a string at the end. Okay, because in Python, working with a list is faster than working with a string. That's why I have a list initialized in here. Okay, and while there is something in the 0 in degree characters list, and we pop off from it. Okay, so I call it a 0 in degree character, and then I append it to the result. And now we traverse across its neighbors. Okay, for a in char in the out to int, and looking at the one we just popped off, So basically, we looking at how can I explain? We're looking at the character that's coming from this character, right? This a in char is coming from here, right? That's why I call it out to in, right? The key being the one comes out, and then this one's the one comes in. Okay, and now after we have dealt with this a zero in degree char, so we can decrease the in degree of this a in char by 1. So it will increase its priority because we already finished one of these higher priority one. So essentially, if we go back here, right? So initially the in degree of b is 2, and now after we have dealt with either a and c, right? So we will decrease the in degree of b to be 1. Okay, and after we dealt with both of them, we will increase. So the in degree of b will be 0, and which jumps to the highest priority. Okay, and this one actually we emphasize the idea that the lower the in degree, the higher the priority. I'll keep emphasize this and this because that's the key to solve this problem. And if the in degree of the a in char is equal to 0, so it means that it jumps to the highest priority class, and then we just append this a in char to the 0 in degree chars list, and then we jumps back to this while loop and then do its labors. Okay, and so if the length of so we keep appending the result to the result, right? And then if the length of the result is equal to the length of the other possible characters, that means we capture all the possible letters in the words, right? And that means we form a valid solution, and then we will return the answer. Otherwise, we're missing out some character or letters we have not dealt with. So we can return an empty string. So this is my solution, and for time complexity, it's gonna be big O of the number of letters in the given words list. Because of this for loop, so is this for loop, right? We have 3 for loops in here. And for space complexity, it's the same because we have the in degree dictionary and also with the out to int dictionary as well. So it's going to be, again, big O of the number of possible letters. And this is my solution. I hope this is helpful. If it is, please consider like and subscribe. Thanks so much for watching. I will see you in the next one.